So the question required us to use graph to attempt this whole question on a sheet of a graph paper. So this is my graph paper. I've taken my graph paper, which is 2 centimeters for each square. So each square here is measuring 2 centimeters. So let me draw my axis. I will start with my x-axis. So this is my x-axis here. Oh, I need to label it again. This is x. So this x-axis I will label -8, -6, -4, -2. So it's this from -8 up to 10 as required by the question, and this y-axis is from -10 up to 6 as required by the question. So this was the scale. If you are correct on your scale, you hardly miss your vertices if you know transformation. Now let's go on part A. We are required to draw here. So let's draw. So the first step here, I will plot my points here, 2 and 2, then 4 and 2, then 4 against what? 5. Then I will join my lines using a ruler. Your lines must be straight. Then I will label my shape A. So this was part of part A. Then we also need to draw shape B or triangle B is required by the question. We again plot 4 against 3, -2 against 3. So this -4 against 3. So -2 against 6 again. And we join using a ruler. Our lines must be straight. I'm emphasizing this. And we label our shape B. Then the next step, we are attempting part B. On part B, the question says triangle A is mapped onto triangle C by an enlargement center 0, 0, scale factor -2. So there were two methods here. You either use a matrices method or you use a geometrical transformation method. So for matrices, you just multiply. Just multiply like this, then you get your vertices. If you know how to multiply a 2 by 2 matrix against a 2 by 3 matrix. Then here I'm going to demonstrate the geometrical transformation method. So the geometrical transformation method needs us to identify the center. So this was 0, 0. So we draw our line from the shape to the center. Then we extend it since it is negative transformation. If you've watched our lessons for transformation under enlargement, we explain this in detail. So check it out on our YouTube channel or in our lessons. So this one we are going to join. I've used a faint line, a very faint line here, so that I do not distort my diagram. So I drew a line from here to here, which was diagonal to 1 square. Then since this is -2, I will extend to be a diagonal of -2, or I will just measure with the ruler. The length here and the length here. The length here must be twice the length here, since it is a scale factor. So my point will be here. I'll plot here. Then here I will draw again my line up to here. You can see that from this top part, this was diagonal to 2.5 squares along y-axis. So this must be diagonal to 5. 1, 2, 3, 4, 5. Or you just measure with the ruler the length here, then you multiply that length by 2, you extend again up to this point. Then for this side, you do the same, diagonal to 2, then it will be diagonal to 4, or you measure with the ruler. So that's how you can use a geometrical transformation method. Then we go on to answer part D, which was rotation. So rotation, we first identify the center. Let's first identify the center. This was the center, which is 2 and -2. So we draw from the first point to this point. I have used a faint red so that you can see. And then we measure this 4 centimeters, and this is 4 centimeters, and this is 90 degrees. 90 degrees is easy, it's just a corner. and it's clockwise. We are coming from the left to the right. Then we do the same for all other points. Here we draw a line up to here, we measure 90 degrees, we come approximately at this point. We do the same for the last part here, we draw a line and make sure you are measuring the length. This is diagonal to 3.5 squares, and this will be diagonal to 3.5 squares, so it will be along here. So I'll do the same. This is for second point, I'll plot. Then for last point, I'll plot and join and label my shape, this shape D. Remember that your lines must be faint so that you do not distort your diagram. Now, let's go on part D, which needs a description of the single transformation. So the single transformation here, the shapes are looking to the same side, which means this was an isometry transformation and a translation. So it moves 6 units along x-axis and 1 unit along y-axis. So 6 units to the left is -6, then 1 unit up this positive. So it was a translation with a vector -6 and 1. Then on part E, we are given a matrix again. So this matrix is 0, 0, which means this is a non-isometry, and this is a stretch. Stretch affects one value, so a vector affects one value here, a single value. Then we start to describe this stretch. We know this is a stretch, but this y-axis, so it's a long y-axis, but the factor is -2. We are given a factor of -2. So that's how you are going to answer. So I will display a clean answer on the screen after this video. So this marks the end.